Now that we've talked about slope, it's important that we look at two special types of lines, which are parallel and perpendicular. Before I do that, I want to do a quick review of the four types of lines that we have. So we have four basic types of lines, or at least slopes of lines. One is we have a line that runs low on the left, high on the right, and that typically has what we call a positive slope associated with it. I'm just going to abbreviate positive with POS. Then you have a line that goes high on the left, low on the right, and a line that slopes like this will typically have a negative slope to go along with it. Then you can have a horizontal line which runs completely flat, if you will, and that type of a line has what we call a zero slope. Now, why does it have a zero slope? Well, let's go back and look at our definition of rise over run for a minute. If I look at this one trying to find the slope with rise over run, how much would I have to rise to get level from this point to this point? Well, I'd have to rise 0. And then I'd have to run some amount. Doesn't matter if I'm going from right to left or left to right, so I'm going to have some number in there. In which case we end up with this having a 0 over any number is just 0. So I'd have a 0 slope. The other type is a vertical line. And on this one, I like to say that this one has what we call a no slope, but we will have some that also prefer to call this undefined. So either slope or no slope or undefined mean the same thing. And essentially what we're talking about is if I'm moving from, again, one point to another point, and I look at it from my definition of what rise over run is, how much would I have to move up or down? Well, I don't know, some number. If I go from here down, it's a negative number. If I go from the bottom point up, it's a positive number. But it's some number for my rise over, but in either event, which way would you have to run? Well, none, because it puts you directly on that point. So you'd have 0. Well, we can't have 0 in the denominator, and so that's why this is referred to as a undefined, or we call a no slope for a vertical line. Okay, going back and talking about our parallel and perpendicular lines. When we deal with parallel lines, and I'm going to rewrite that again here. When we talk about parallel lines, we will use this symbol, two vertical lines side by side, very close together, unlike absolute value where the lines will be a little bit farther apart. These two lines are side by side with each other, and all they mean is this. If I have two lines, and I'm just going to draw two lines, and I'll use my same subscript, so I got L sub 1, and then I have L sub 2 for my two lines. How I know they're parallel, there's a lot of characteristics. They'll never touch, they'll never cross, and we know some of those types of things. But what makes them special is this, that the slope of M1, line 1, has to be equal to the slope of M2, or line 2. So the key to making them parallel is that their slopes have to be identical, and that's what makes two lines parallel to each other. When we talk about perpendicular, I'll try and fit that in on the side here. When we do perpendicular, we'll use an upside down capital T to represent perpendicular from here on out. And I'm going to draw two lines for you that are perpendicular to each other, but not vertical and horizontal. I don't want to go through kind of the special case. I'm going to draw two lines that look a little bit more like this. We'll call this L1. We'll call this L sub 2. And I know that these two are perpendicular, partially because by a characteristic they form a right angle. A lot of you know that you've heard that before, that perpendicular means that they're right angles. But by a definition, here's how perpendicular works. If the slope of this one, since it's low on the left, high on the right, it's going to have a positive slope. Let's say that its slope is A over B, some number over another number, but it turns out positive. Well, from kind of a working standpoint, then the slope of L2, it's going to be a negative, it's going to be the opposite, and then what happens is we take the reciprocal of whatever m sub 1 was. So this would be a b over a. More importantly, when I look at the product of these two, if I multiply m sub 1 times m sub 2, that product should equal negative 1. If I take this number times this number, it should give me a value of negative 1. And that's what makes two lines perpendicular to each other. Okay? So as just a numeric example for you real quick. So if m sub 1 had a slope of a positive 2/3, then m sub 2 would have to have a slope of a negative 3/2. Notice they're just opposite reciprocals of each other. So parallel lines, same slope. Perpendicular lines, their product is negative 1, or another way to think of it, their slopes are opposite reciprocals of each other.